Hi everyone, it's really nice to be here in Amsterdam. I'm Anna from Hive, and as Martin mentioned, we do sort of smart homes platform. I'm on the team that develops the front-end facing applications, mainly in React Native these days. And for about the last 6 months, I have been focusing on making those apps performant, mainly because old Android devices do struggle with that a lot. So we found out quite a lot of stuff about how to make the apps performant, which I would like to share with you today. And performance is one of the tricky topics that seem to be very important. You know, everyone wants to have performant apps. Performance is one of those interesting wildcards in any discussion between developers. If you say a library is performant, everyone will give you a thumbs up for it. But at the same time, we do very little measurement. We don't actually, look into benchmarking. We do very little of actually trying to understand what our code is doing. So very often we pre-optimize, we did a lot of that. We created a lot of patterns in our app that we thought would be performant, and that turned out completely wrong. So today I would like to share the patterns we found out, but also explain to you how we arrived at them and how some things work in React Native and React in general, so that later on you can yourself go and see how your app is doing and see if some of the things that we found were useful for us could be useful for you as well. The general issues we were facing in our React Native app were things that probably a lot of people would face. A lot of it were about slow startup time of either the whole app or the pages as we were navigating to them. And the other section of issues was coming from slow response time to whatever the users were doing or having sort of not smooth animations. And most of my talk will be focusing on the latter because that was the #1 thing that we had to address ourselves. It also happens to be possible to address it relatively simply by just tweaking your React code, the JavaScript code. And at the end of the talk, I will be talking a little bit about the native side itself and how to address some of the slow startup times and stuff like that. So when we were facing the issues, we needed to figure out what the weak link is. Now, I'm running out of imagery, obviously, but it's difficult to show the infrastructure of React Native with like sensible images. So essentially, we've got 2 threads and a React Native bridge that connects them, at least for now. The UI thread is the one responsible for the native stuff, for actually rendering things out on the screen. The JavaScript thread is the one that is responsible for running React and all the JavaScripty bits and changing state in Redux or whatever. And then React Native bridge communicates between them. We originally made the assumption that it's the UI thread that is struggling in our application, or potentially that there is like slow communication over the bridge. But that was just like a very vague idea, and we decided to use the perf monitor that comes out of the box with React Native. It's literally in the developer menu. A box like this pops up on your screen, and it sort of shows you very roughly what is going on the inside. What interests us most here is the UI and the JavaScript on the right side. Ideally, we want it to be at 60 frames per second because that shows that the user is having a good sort of experience. But it doesn't always happen. In our case, we saw the JavaScript thread especially dropping a lot. I even saw something like -30 frames per second, which I don't even know what that means. You know, like how can you have negative values? But there you go. So this was kind of a conclusive or semi-conclusive pointer towards the JavaScript thread, which we did not expect, because after all, when you think about it, it's not doing that much really, or that's what we thought. But it turns out that state change is quite complicated. And we realized by wild experiments of commenting and uncommenting code that the state change is the thing that makes our app slow. Till this day, we're not entirely sure why, but we know that this is where a lot of our problems lie. The moment you change the state, something happens in JavaScript that then sometimes produces some effect in the UI thread. But to understand how to make this more efficient, we needed to look into how the whole process works. So this is very roughly how things happen when you change something in your state or props. If you have a change, React then goes and tries to figure out what render functions or stateless components need to be run. It sort of creates an updated version of the virtual DOM tree, figures out what bits actually need to be re-rendered in the UI, and then the actual rendering in the UI happens. But as you can see, there are quite a few steps before it goes to updating UI. There are a lot of things that happen in JavaScript just as you make even a simple change. Obviously, if you make one change in 60 seconds and it's a small one, it's not going to cause issues. But sometimes you update state a lot, and that's where these things start becoming very slow, especially on old devices. This is our application. It's the dashboard which I'll be using as an example. It's the first thing that users see when they load our application so that they can control their products. And obviously there is a lot of state going on here, and we had a lot of problems where it was very slow. The UI itself is relatively complex because you've got a lot of different pages and different products, different cells. All of this needs to be updated in real time so that the user actually sees what's happening with their devices. And we have been struggling to understand why this screen is slow. Since it's the first thing a user sees, we need to make sure that it's super performant, but it was taking around 7 seconds to render, and that is way too long, and that's minus the actual start of the application. This is just rendering the screen. And to understand why what kind of state changes were happening, why it was slow, we were using the performance tab. It's both in React Native Debugger and in the Chrome DevTools. And you can pretty much measure or record anything that's happening in your JavaScript. And obviously, this flame chart is kind of hard to understand, so let me walk you through what was happening on that dashboard. The first bit is just mounting the general infrastructure of the application. It's mounting the provider and the translations, etc. Then the next bit here is the actual mounting of the screen and the first render. That is super efficient. As far as I'm concerned, at this point, we could stop, and stop rendering. This would be some 1.5 seconds, which is okay, I guess. But then you're going to see that there is a lot more going on later on. And this is essentially showing us that we are re-rendering the screen 3 times extra. And I would still understand the second one, the middle one, which is probably due to update to the state of the devices. But everything else, we weren't quite sure why this was happening. So this was a very useful pointer because we realized that not only state changes are slow, but they are happening way too much in our code. Well, the usual answer to this problem is should component update. It's like, my favorite question in interviews is how do you make apps more performant? And every single person says you should component update. It's fair enough, it's in the React docs as well. But actually we found out that it is the unexpected villain in our story. It caused so many issues that we ended up removing it from all the places in our code because it actually caused more bugs than solved performance issues. Let me quickly illustrate the problem. If we have a component that renders a name and a value, and for some reason we only care about re-rendering if the name changes, we can use should component update and say only re-render when the name changes. If the value changes, nothing will re-render, things will be faster. 3 months later, another developer comes in and needs to add a description. So they add a description, but forgets to add it to the should component update. And then suddenly we have the wrong description at the wrong times, and we are wondering why that is happening. In here, it's very easy to spot it, but if you have nested views where you're passing props down the trees, and there is a should component update somewhere in between, if you have 25 developers working on things, if you've got huge APIs with like 20 props on one component, it's really, really difficult to figure out why things are not happening the way you want them to. And frankly, we would much rather choose low performance over buggy interface. So we removed all of those, but fortunately, there is a much better solution for making things performant in JavaScript. The fact is, React is super smart on its own. It really knows how to figure out well when to update the tree. There's the reconciliation process that was briefly mentioned, and it has like just two relatively simple rules. If the node type changes, it scraps all the children components and remounts new structure. And if a prop or state changes in a component, it re-renders itself and then goes to check the children if they need to re-render as well. This is based on shallow equal. That's why we don't want to mutate state so that it re-renders when it needs to. And all of these changes propagate to all children. So if a change happens on the top level component, it has a far worse effects on performance and re-rendering than if it happens on a low level. And a few quick examples. If we have, for some reason, a component that switches two wrappers on top of the component, every single time we change the type of that wrapped component, we will re-render all of it. Not just re-render, but also remount. So there's relatively a lot of computation power that is required for this. And then if we change the prop from, let's say, from hello to hello world, again, we will have to go to the low-level component and re-render. This is not a problem on low level again, but once you start doing it throughout your whole tree, it will sort of like build up. And as I said, there are the recursive updates. So that means if you do something on top level, everything will, well, not everything will change, but it might. So React does need to go to check if it needs to do some work on it. So let's have a look at examples of like how do we then practically use this knowledge to not update our UI views too much. The first and foremost thing is not using anonymous functions. It's one of those pet peeves in all our codes where we have an on-click function and it's very easy to just slap an arrow function in there. But the problem is that this way, every single time we need to re-render parent, we need to create a new reference, and as there is a shallow equal, this reference will keep changing over and over, so the child component will re-render every single time. Again, if this is something that you do on top level screen, it's really bad because it has a knock-on effect on everything that's underneath it. We even have the squiggly ESLint warning there saying that we should not be doing it anywhere in our code base. It's much better if you define it outside of your component or as a class method. We do that a lot as well. A far bigger effect on performance, I believe, is the connect and the way we connect React to Redux in our components. In this example, we have some component that needs to track itself when, let's say, it mounts. And we don't want to, we want the component to be quite dumb, so we don't want to give it too much information. So ideally, we just want to give it a track function that will do the whole work on its own. That way, it makes it look cleaner in the component. But the problem is that merge props will always create a new function reference, which means that all of this will re-render, all of the children will re-render. The same goes for map dispatch to props. Now, connect and all of these mapping functions get run anytime you update your Redux store. And that means that that will happen a lot. In our case, we've got some 100 reducers, hundreds of sagas. The state updates all the time. And that means that all of these functions run all the time as well. So we need to make this much more performant. And we do that by scrapping merge props. Essentially, we don't allow anyone to use merge props at all in our codebase anymore. And we are trying to use all map dispatch to props as objects, because that way the references stay the same for the whole time of the component being up. And then we've got the state, or like the state props, and we are trying to make these very simple. So ideally a number or string which in shallow EQ would not change as a reference. Or if there is an object, we are looking into memoization. As I said, when we have the selectors, there are two issues potentially with selectors. One is it could take a lot. In this example, we've got an array of items, and every item has an array of children, and we are looking for an ID somewhere in there. And obviously, if you have a lot of these and you run it every single time something changes in your store, it could take a while. So ideally, we want to memoize. We are using the create selector from reselect, but anything will do as long as it does some sort of smart memoization. And also, ideally, this will not return new references to objects every single time you create a new object if it is memoized. A word of warning, obviously memoization brings its issues as well. If you memorize huge amounts of data, the memory will suffer. Also, sometimes like with immutable, for example, or with like weird data structures, you might get strange behaviors. So it's good to memorize, but like be a little bit cautious about it too. So that was the best practices for like the particulars, but the way we handle state and the way we update state in general is also something we really want to look into quite a lot. So when it comes to updating local state, there is this whole concept of updating inner state based on props. I think we have all done it. But there is, like a general consensus this is not a good thing to do. Sometimes we still have to do it though. We used to do a lot of the top pattern of sticking set state into component did update, but that essentially means that you render twice in a row. First for the props being updated and second for the state being updated. So in that respect, it's better to use the get derived state from props, because that way you do this process just once. But from our perspective, it's even better to put everything into the mapping function or somewhere like that, because that way you sort of like extract it away from setting local state at all. We also try to update local state only when necessary. That's especially true if you're, let's say, there is a button and you want to say, yes, the user has clicked the button. You only want to do that once. So always make sure that you're doing only the updates that you find necessary. Another thing that I don't have an example slide of is we sometimes use state to sort of memorize things, like so that we don't have to run something every single time a render function runs. We slap it into a state, into a local state. But again, that's sort of a misusing of the local state. It's much better to use some sort of like outside memorization algorithm for that. When it comes to Redux state, that's in many ways much worse than setting local state, because it, as I said, it runs all the connects, and if you have a lot of those in your application, it will cause a lot of re-renders, or just a lot of performance hit. So ideally, we are trying to use local state for things if we can. So for us, Redux state is essentially just holding the data about the devices, etc. We don't want to have any UI state whatsoever in Redux. A typical example is, instead of using information about whether a module is open or not, we would like to keep that in a local state or use context or something like that to sort of localize the impact of that state change to the tree. We also found it very useful to batch Redux actions. That's mainly like on startup, we would dispatch at one point about 20 actions to get config and fetch this and fetch that. And that was slowing things down significantly. We then moved all of this into just one action, and then all the different reducers would just listen to this one action, and the same for sagas. Equally well, it's sometimes worth, if you're using Redux sagas, it's sometimes worth, instead of dispatching an action to run another saga, it's better to call the saga directly. That way, again, you will save a little bit extra power. And then the way you connect state, this is a little bit controversial, because I did say that the connect and the mapping functions get run every single time you update state. But imagine that you, which we did, that you connect a whole screen with one connect so that you save up on that. But that means that you then have to pass all the props down the whole tree. And sometimes the tree isn't just 3 levels deep, it can be 10, 15 levels deep easily. And if you have to pass the props down, you have to re-render every single level of it so that you then get the result at the very sort of low-level component. And we realized this is actually by far the worst thing. If we are connecting things much more locally, that way we are updating only the part of the app that we actually have to update, and we get a lot of performance boost out of that. So the general conclusions when it comes to JavaScript is, it's usually the JavaScript thread. Let's face it, like, most of us will never do anything so complicated in the UI that it will start impacting the UI thread. So look at the perf monitor, and it will likely show you that it's the JavaScript thread struggling. Always measure before acting. What I have shown you of like the measurements and the problems we found they apply to our application, it's quite possible that your case will be very different. Think about reconciliation and state updates as you're writing your code. These are the patterns that we actually find quite useful to use, even if there are no immediate performance issues. Because if you write it from scratch, thinking about how the state would change and propagate throughout your app, you will then not have to deal with it later on. And memorize where it's wise to do so. So that was the JavaScript side, and now I would just quickly want to run through a few native-only issues or how to use things and debug them. The first thing is animations. It's one of those things that everyone always focuses on. We actually didn't find them being a huge problem in our case. Sometimes we defaulted to creating native components for something that was very, very animation heavy. You can obviously use reanimated, but most of the time for us, it was just enough to use the React Native animated library and the use native driver true. That actually made all the difference that we needed. RAM Bundler is an amazing tool for the long start. What it essentially does is it looks at the modules that you're requiring in at the startup, and if there are some that you don't need immediately, it's not going to load them in. And that shaves off quite a few seconds, especially if you're using a lot of native modules. So for example, if you have something like, I don't know, code push or camera or like some hardware access libraries, it's much better to put them inside an inline require so that they are only required as and when needed. Similarly, we found out that inline requiring images was a huge boost to the memory consumption. When we turned all the images into inline requires, our memory dropped by 150 megabytes on startup, which is a huge amount. So it requires a lot of refactoring around the inline requires, otherwise it's not going to give you the boost. It also has different configuration in every single React Native version, so I'm not even going to go into that. But in version 59, it comes kind of out of the box, so it's quite easy to just try it out and see what it does for your application. When it comes to measuring, it's one of those things that I actually found as a JavaScript developer very complicated. I would say use profilers. They are both for in Xcode and in Android Studio, but using systrace was something that really helped us debug the Android issues. It looks really cryptic. This is like a tiny screenshot of a systrace from Android, but it sort of shows you roughly what the app is doing. The green thing here is the JavaScript thread at the startup. It's one of those things, again, when we were trying to figure out why does our app take such a long time to start up. Looking at the systrace, we realized that it is, again, the JavaScript thread, surprisingly. And then we needed to add some extra logs around it. There's one issue with React Native in this respect, and that is that Facebook has a lot of internal tools that they use to understand the performance that we don't have. So we needed to sort of, create our own performance logger to understand how what this thread is actually doing, because it's not in the systrace. So there's a lot of sort of low-level nitty-gritty things, but once you get the hang of it, it really can tell you a lot about what your app is doing and how you can improve on it. One last thing that we actually struggled insane amount with was routing. And that is, as we came from web, we decided to use React Router native. And that was a horrible mistake, at least in our case, because it essentially is using JavaScript to do all of this, the animations, the change of state, and it was slow. So as we have seen, the JavaScript thread is already struggling the way it is without navigating. So 12 months into our project, we had to stop all work and strip out the navigation and replace it with a new one. And it's interesting how how much work that is. So I would say if you're starting a React Native app, definitely avoid React Router Native. It will cause problems down the line. I'm sorry, but that's a harsh truth. The most popular library, I believe, is React Navigation, which is somewhere between native and JavaScript solution. We are using the React Native Navigation, which essentially is all done in native code with just like a thin JavaScript wrapper. And we did that for the reason that we just didn't want to deal with, yet another potential issue later on. But I think both of them are quite good solutions. So just to sum up, very overall, optimize wisely, make sure that you measure first, that you understand what the code is doing and how to improve on it, use all the tools available, and if you have any questions about anything that I have been talking about, please do let me know. Thank you.